Hello everybody. Today's topic is the ambiguity in context-free grammar and the context-free languages. So far we have discussed in our previous classes that what is the context-free grammar and what is context-free languages, okay? And what is the left derivation tree and what is the right derivation tree. Now come to the ambiguity. What is the ambiguousness of the CFG? The ambiguousness is nothing but the same method or same derivations we will apply. The same derivations we will apply in our production source to have the particular string. To have the particular string in a production source, if I can use more than one derivation methods. That is, if to have the some string in production source, if I will use the left derivation 2 times, so then the context-free grammar will have the ambiguous nature. That means if a context-free grammar has more than one derivation tree for some string, it is called an ambiguous grammar. That means there exist multiple rightmost or leftmost derivations for some string generated from that grammar. So if to have some string in a production source, I use more than one left derivations methods or right derivations methods, then it will be ambiguous. So here is the problem. Now check whether the grammar G with production rules, these are the given production rules, if you have to check this is ambiguous or not. Okay, so for this I choose the leftmost derivations to have this string. So what happened? For derivation 1, x produces x plus x. I am starting from this, and if I have chosen here the left derivation, so I choose x and I replace this by a. Again I explore the x as x star x, and again I choose this x, left side x, and put the value a, and the last of all I put a, and I got this string. So this is the left derivations. Okay, to have this string I used here the left derivation method, and the parse tree of these left derivations is like this. In the previous class you also understood that. Again come here the derivation 2. Also I am starting with x produces x star x. That means x produces the second one x star x. I am starting with this production rules. And here also I have chosen the left derivations method. So here now at first I explore this x and x plus x and star x, and choose the leftmost x. This is a, and put the value of a. Again I choose the second left element x and put a also, and the last of all I put the value of x with a. So here also I obtain this string. Now these productions rules, this is the left derivations rules, and these also the left derivations rules, but to have the particular string, here the left derivations technique is different from the left derivations techniques I have used here, and the structures of both the methods is like this. The parse tree for these left derivations is like this, and the parse tree for the another left derivations is this. That means what is the difference? To have the same string, I have used the left derivations in different ways. Here I have used the left derivations method. Here also I have left derivations methods, but the parsed structure is different. So this nature in the CFG is called the ambiguity, and this CFG has the ambiguous in nature. So this is the ambiguity in context-free grammar. Okay. Now the new topics for today is the push-down automata. What is push-down automata? Another videos what I have done in my exercise book, I will upload afterwards. And here actually what happened? What is push-down automata? So the push-down automata is nothing but the automata which will accept the context-free language. So far we have obtained that the regular grammar always produces regular languages, and regular language is always accepted by the FA, that means finite state automata, or FSA or FA, finite automata. But the context-free language CFL is accepted by the push-down automata. So what is the difference? The regular language will be accepted by the finite automata, and context-free language will be accepted by the push-down automata. In push-down automata operations, we need, this is the structure of the push-down automata, that is FA plus a stack. Here the stack is very important. For the infinite informations, we need the stack. For a finite state automata, just we have dealt with the finite number of states. But here we will deal with the infinite number of states. For infinite number of states, we will use the stack. So the push-down automata is nothing but the combinations of finite automata and a stack. Okay. What are the components of the push-down automata? An input tape and control unit and a stack with infinite size. Okay. So here are the two most important operations which will be held on the stack, that is push and pop. Push means the symbol is pushed to the stack, and pop means the symbol is removed from the stack. Okay, this is the diagrams of the operations of the push down automata. That is, this is the input tape from where the particular state will take the inputs. Particular state. In the previous classes, I make understood you that how the state will take the inputs and shift it to the next state. Okay, like this. Here from the input tape, the input symbols will be taken by the states, and simultaneously what happened for the stack operations also parallelly will be goes on. That means in the stack, for taking of the inputs from the input tape, some symbols will be pushed to the stack, and sometimes the symbols will be popped from the stack, and after that the state will be shifted to the next state. Okay, this is the fundamentals what I am telling you. That means from input string, from input tapes, the input symbols will be accepted by the state, and parallelly the push and pop operations will be held on the stack, and ultimately the state will be transited to the another state. That is the fundamentals of the push down automata. Here the tuples of the push down automata is like this. What is the queue? All are the abbreviations. the descriptions of all the tuples. The Q is the finite number of states, sigma is the input alphabet, S is the stack symbol, and delta is the transitions. And here the transitions is Q will take the input, and again the stack symbols is red, and it goes to the 2 to the power Q into S. That means infinite number of states and the status of the stack symbols. That means that is the transitions, ultimate transitions of the PDA. And Q0 is the initial state, Z0 is the stack top, which is more important, and what is F? And the F is the final states. So this is the diagram, the shortest diagrams. That is the input symbol is A, and the stack top symbol is B at that time, and the push symbol is C. That means Q is accepting this input from the tape, and the stack top B presently will be pushed with another symbol C, and in this time the Q1, this state, will be shifted to the Q2. That is the fundamentals of the PDA, push down automata. For the next videos, I will upload the next videos where I will do some exercises on the PDA in my exercise book. So for this time, thank you very much.